Hello everybody, getting ready to do lesson 12.6 or pre-algebra part 1 today. If you need classwork sheets or homework sheets, email me here. Today, 12.6 quadratic functions. We have 17 points here for notebook taking, and then we got a 36 point here for classwork sheets today, so you should get those if you don't have them. Teachers, today's spell work. We have multiple choice here, which expression is equivalent to that. And then write a polynomial for the area of this triangle. So, excuse me, write a polynomial expression for the area of that triangle. Give your students 5 minutes for this, teachers. Okay, welcome back for our solutions here for today's spell work. There is an equivalent expression here. Will be a negative 64 over x to the 6th power, so it will be b for number 1. And then 1/2 bh, and then we have our b times h here. We multiply your two binomials through. And we're using this distributive property here to multiply your binomials. You have this expanded expression here. You combine like terms and you come up with this trinomial for the area of that triangle. Okay, today's lesson is about quadratic functions. You've graphed linears, you'll graph quadratics. And so we start with an acrobat is launched into the air from a teeter board. The acrobat's height in feet is, here's a herd acrobat here, is given by the function here, a negative 16 t squared plus 32t plus 3. This is a parabola, so where t is the time in seconds, so we have a function here that includes t for height. What is the greatest height that the acrobat reaches? Okay, so how are we going to do that? Here's an acrobat too. The function h equals negative 16t squared plus 33t plus 3 is a quadratic. A quadratic is an equation in two variables that can be written in this form here, ax squared plus bx plus c, where a, b, and c are constants and a cannot equal 0 here. Okay, everybody, continuing on now with our first example here. Of acrobats. We're featuring acrobats in this lesson. Here's an acrobat. Evaluating a quadratic function. So what we have here is a table. To make a table of values for this quadratic function here, we're going to substitute several values of x into this equation here for x, then simplify to find the corresponding values of y. This is y here. So here's our setup for our table. Here's our x column, here's our substitution, and then here's our y column here. So when we substitute negative 2 into this quadratic here, and then we substitute it in to our quadratic, what do we get? Well, let's simplify. 2 times negative 2 squared would be 2 times 4, plus 3 times negative 2 would be negative 6 plus 1. What does that equal? It equals 3 here for when you substitute negative 2 into this quadratic. When you substitute negative 1 in for x, we substitute negative 1 here, and we get 0 here. So the 2 times 1 would be 2 plus negative 3 plus 1 would equal 0. And then when we substitute 0 in for x, we get 2 times 0, we get 1. So when x equals 0, y equals 1. There's your y-intercept here on this parabola. And then when we put 1 in for x, we get 2 times 1 squared plus 3 times 1 plus 1. That is 2 times 1 is 2 plus 3 plus 1 is 6. When we put in, when x equals 1, y equals 6. And then we substitute 2 into our quadratic. We get 2 times 4 plus 2 times 2 rather. 2 times 4 is 8, plus 6 is 14, plus 1 is 15. So when x equals 2, y equals 15. So that would be a way that you would find values for y when you substitute values of x in. Or you could do it with a calculator. So there's your table for y equals 2x squared plus 3x plus 1. This would be how you would do it if you're going to do it by hand without a calculator. Okay, make a table of values for the given function. So we're going to continue here making tables for these quadratics. Students, this is yours down here. Pay attention up here as we do our guided so you know what to do. Y equals 3x squared plus 6x minus 9. And then we have y equals x squared minus 4x plus 7. I don't know if I'm going to do this for you. I might. So here is your first table here for this quadratic here. When you substitute in these values here, you substitute this in for x, and then you get your y values here. This would be a way that you could plot a graph. When x equals 0, y equals -9. So it'd be a rather large graph here of this parabola. And then etc. When x equals -2, y equals -9 as well. And then, so your graph goes something like that. And then when x equals -1, we get y equals -12. So anyway, I'm not asking you to graph here, just make a table. And then do that for your independent practice here. Do I give you a gift? I don't. So anyway, moving on. So graphing quadratics, now that we know how to make tables, the graph of a quadratic function is a U-shaped curve called a parabola. A quadratic function is an example of a nonlinear. It's definitely not linear. A nonlinear function is any function whose graph is not a line. So parabolas are definitely nonlinears. Students, in your own words, define quadratic function and define parabola in your own words. Put this in your notebook, page 6 on for this lesson. I do vocabulary checks on Fridays, so students, enter this 10 points here, okay? And then nonlinear function here, again, students, in your own words, define nonlinear function. Points. Okay, into our next example here, graphing a quadratic function. So we're going to graph y equals 1/2 x squared plus 1. So we're going to make a table here. Step 1, make a table. So we're going to substitute values of x, and then we find out what we get for y. So when x equals -4, we get 9. When x equals 0, y equals 1, etc. You could do this too by punching this into your graphing calculator to find that. Okay, use the table to make a list of ordered pairs. So now, here's our ordered pairs, -4, 9, -2, 3, 0, 1, 2, 3, 4, 9. I mean, this is an ordered pair for plotting points on your graph. Graph the ordered pairs and draw a smooth curve. So here's what your graph will look like for this parabola here. -4, 9 way up here. -2, 3, and then 0, 1, and then 2, 3, etc. 4, and then 9 over here. And then, okay, we won't get into that, but that will be your plot right here for this parabola. Okay, make a table of values for the given function here, and then graph the function. Students, this is yours. Pay attention so you can actually do your independent practice. And let's do our guided up here. So here's your table here for this quadratic. 0, when x equals 0, y equals -2, etc. here. When you plug in these values here into your quadratic, here's your ordered pairs to help you organize what you're plotting. And then when you make a plot of that, you should get a graph that looks like this for this quadratic here. It looks like when x equals 4, y equals -18 would be your vertex here for this quadratic. So that's what it should look like. Students, this is yours. Okay, and that would be 12.6, part 1. Part 2 is available here. Worksheets, tasks, quizzes, tutoring. Yes, I provide tutoring. Email me for that. Thank you very much.